morning, DevOps Days Prague. I'm so thrilled to be here. We mentioned a few minutes ago, the soft skills we are thought to be lacking. So the marketing department asked me to take a picture of myself with you. So if you don't mind just saying a hi for me, to do a selfie here. Hi. Sorry, guys. So let us jump into this. Okay. So what we're going to talk about today. I myself, security professional with long history of both offensive and defensive security, and turned into the world of DevOps and cloud a few years ago. And I think we are working really hard in the Kubernetes security space, and we thought that it would be a very interesting thing to compare the security of open source project and the general population of the security posture of the general population. So we created this research, which we are going to talk about today. So, again, as someone who spoke in a lot of conferences before, and gave a lot of cyber talks. Usually cyber talks are very frightening, and you are going out and like, oh shit, everyone is after us. But I hope that today is not going to be this kind of talk. I think that it's going to be a more interesting and refreshing talk. Just again, a few things about me. I'm a maintainer of Kubescape, which is like as a full disclosure for this talk. CTO and co-founder of Armo, which is a small Kubernetes security startup in Israel, and contributor and speaker at different CNCF events and working groups. So, what is our starting point? As when we started Kubescape, we thought that it's very important in the Kubernetes security space to have a security posture tool, something you can use to check yourself against the best practices, both at the Kubernetes infrastructure layer, whether your, API server is set up securely and so on, or your kubelets, and both at the workload level and RBAC level. So we created this tool which enables you to read actual different configurations, scan for vulnerabilities and so on, scan your network and so on, and create a security posture report. How secure you are, and what are the things you have to fix in order to be more secure. This is a lot of information which we are giving you. And in Armo, we built a platform, a SaaS platform behind this tooling, which enables you to manage this information more properly. But in general, the idea here is that Armo receives a lot of security posture information, and we store this data for our users. And it's awesome because we have a lot of data. So what do we do with a lot of data? We start to play around with it. And this is the thing which gives us today the core of the research I'm presenting to you. This is where we are getting our information from. So again, with Kubescape, you can both scan your active clusters, you can scan your GitHub repos or other Git repos, you can scan your YAML files, Helm chart, and so on. You can scan your images inside a Kubernetes cluster or in a container registry. And this data is being uploaded to the Armo platform, which is a SaaS system. And just to give you like a very broad perspective on the numbers on which we've been working with, when, like half a year ago, when we freezed the data set and took the sample, which is the basis of this talk, we had around 60 or 70,000 active clusters reporting to our backend. We've seen more than 40 million Kubernetes objects, workloads objects. We've seen nearly 170 something, 78 container image registries. We've seen nearly 2,000 container repositories, and we saw like a lot of things. We have a relatively, I think, big data set which we've been working with. So this talk is going to have two parts. One part is talking about the configuration of your workloads, how you are running on Kubernetes your workloads and how is their configuration, and what are the security-related aspects of these workloads which we took into consideration and can say that whether this has an effect on the security posture of your workloads. This is the first thing we are going to talk about. The second thing is actually the vulnerabilities inside the container images which you're running your workload with. So we're starting with the configuration part. And during this talk, what we are doing is actually comparing two kinds of workloads or container images. One is what we call a general sample, which is like everything. And the second is the list of graduated images and workload definitions from CNCF graduated projects. Why graduated projects? Since I'm at DevOps Days, I hope I less need to go into what's the meaning of graduated projects, but we thought that it's the right thing to look into, if we want to consider and look at good, well-maintained open source projects and their security posture and get some info out of it. Graduated project is actually a good definition. Graduated projects has some quality control by CNCF, and I think it's a good thing to, like, when we're comparing open source versus non-open source or general sample, it's a good thing to look at. We are going to look at different aspects of the configurations, and we'll check the ratio between we'll compare the ratio between the general sample and the graduated sample. So just a few words about comparing about the definitions and names we are going to use. So in the terms of Kubescape, control is a single test. It is something which either fails or passes. But for example, just giving you a very, very rough example, if you have a privileged workload from a security perspective, if there is a control which checks privileged workloads, it will fail on a privileged container and it will pass on a non-privileged container. So it checks a single aspect. A framework is a group of controls. For example, there is a framework which we call NSA, which is the NSA Best Practices Framework, how to harden your Kubernetes clusters, and it's made of a set of controls. The same goes for MITRE best practices or CIS compliance or PCI compliance. You have frameworks which are like, have all these controls, and the frameworks are give you a rough idea of where you are standing from a compliance and hardening point of view. So there are different controls and which we have. Here are a few examples. I gave you the privileged container example. Another example is whether you have a service account token is mounted inside your container, or whether your container is exposed to external traffic and so on, or it has a critical vulnerability. But in general, what you have to also know is every control has its severity, which is like an added property to it. And, you know, for example, if you are working with the system, you can say, well, I want to start with the critical and high severity problems and only address medium and low afterwards. But this is, in general, how it looks like. So the first data we created was actually comparing our different frameworks, and this doesn't contain the CIS because we didn't have enough data. It was released only in November, December last year. And as I told you, in January, we frozen the data set. So this is the only MITRE, NSA, CISA, our best practices framework, and DevOps best practices are in this graph. So what you can see is what's the general score against this frameworking? How many controls are failing? So in this case, the higher number, is the better, because you are more close to the good state. So as you can see, the hardest to be is somewhere around the NSA CISA framework is the hardest to achieve, and the MITRE is after it. Our own security framework, which is our own best practices made of controls we think are the best, is somewhat less, but you can see that all of them are really close. But the DevOps best practices, which we collected, and it's a very well broadly used control set, it is somewhat much better than the others. Now, if we're looking at the different controls in the general population, I know this is a hard graph to swallow, because there are a lot of things and small fonts on the screen. But the first thing you have to know that we counted for every control how many failures we've seen. And you can see the first one is a control of immutable root file system. We'll talk about it a little later. I will a little bit elaborate on those as well. But you can see that there are somewhat, I would say these numbers are really close to each other at the beginning. You can see the first 4 or 5 are really close. For example, mostly you have as much non-root containers as immutable file systems, or as much resource limitless workloads as workloads who are allowing privilege escalations. But somewhat afterwards, we are seeing a drop. We'll look into that later. But the interesting thing is, if we are comparing this to the graduated project sample, we can see that some of those controls are moved backwards. For example, immutable file systems and missing probes have swap placed, and non-root containers are a little bit less. This is an interesting thing to look at, because it means that somewhat the way these projects are defined look different than the general population. So I asked a friend who is a Linux expert last week. I asked him a question: does it matter if a container is running root processes? And let's say that the container dropped all the Linux capabilities, whether it matters that the processes running inside them are root processes. Now, the general approach is, and the best practice is, not to run containers as roots. Having said that, as you can see, in the general sample, 91% of the population is running containers as root, and in the graduated project, 83%. I wouldn't say that this is a huge difference, by the way, between these two samples. There is a slightly graduated projects are better, but there is not a huge difference. So my answer is, as a security expert, is that in general, if there are no vulnerabilities in the Linux kernel, there is no difference between running your container as root as opposed to non-root from a security perspective. If you have dropped all your capabilities, and by the way, Kubernetes and most container runtimes are dropping all the capabilities by default, there shouldn't be any problem. The problem comes when there is a vulnerability inside the Linux kernel, and if your process is inside the container running as root, there were a few examples of vulnerabilities which show that if you were running as root, you could escape the container with the kernel vulnerability. If you were running as non-root, you couldn't. So therefore, this is still this is a good practice, a second line of defense. If we are comparing immutable file system control, for example, you can see again that in the general sample, we nearly never found any containers who were running inside the container which the root file system was read-only. This is a good security practice. Again, if you're running your workloads, it is much better to run them with read-only file system than enabling anyone to write anywhere they want inside the container. It's a little bit hard to define workloads like this. So again, it doesn't surprise me that 97% of the general sample is failing logics, and 92% in the graduated projects are not, because it involves a lot of configuration to achieve this. But on the other hand, and this is a Kubernetes specific control, not a general container problem, automatic mapping of service account tokens. And here I say that this is, as I see it, this is a real thing that I think a big thing that people should be aware of. So, Kubernetes automatically, because of historical reasons, mapping service account tokens into every container. Now, the only containers who needs this are actually those who are talking to the Kubernetes API, which are, I would say, only the management layer or operators and so on need this, and most of the applications, like 90% of the applications, doesn't need this. You can see that 81% of the general sample doesn't disable this automatic behavior, and I would say somewhat less in the graduated project space, 69 are not defining this. This is as I see, a problem. Now, whether people are applying security contexts to their containers is, again, an important security factor. Removing, changing the default user ID and group IDs inside your container, disabling privilege escalation ability, adding even SecCom profiles and so on, or SE Linux profiles is a very good protection against an attacker who enters the container and tries to do something inside it. 61% of the graduated projects are failing on this. 77% of the general sample is failing on this. I thought that 77% was surprising for us because we said that there will be much more failures, but it was a good start. So if we're comparing in general, all the controls we are looking at, the probability of control failures in a single workload for graduated project is 35% in graduated projects and 38% in general sample, which means per resource, which means that there is a slightly graduated projects are better. So we are moving to the second part of the talk, which is the container image scans. So again, the same thing what we are doing, we are looking at the CVEs or vulnerabilities, known vulnerabilities inside the two samples, and we'll go to whether they are really relevant for us. So I'm sorry, we don't have a lot of time, so I will a little bit speed up. Hope keep up with me. So the most image repos, okay, with the most image scans were Argo CD, Redis, Prometheus, Sidecar project, MongoDB, Node Exporter, and Agent. In the graduated sample, since most of a lot of the previous list was also made of graduated projects, you can see also here that Argo CD is here, Prometheus is here, but obviously other things which were not part of it disappeared. So what we did is scanned all these images. We took all the image scans and compared the two samples. And what we saw is actually how they fare against each other in what's the probability of having, for example, a critical vulnerability in a container image. You can see that for example, here in the graduated sample, actually you had more probability to have a critical vulnerability at the beginning than in the normal sample, which was kind of weird. On the other hand, in most of the others, for example, high and medium, no, medium is also, the graduate sample is bigger, but we actually had some kind of disparity. We started to look at the top vulnerabilities, and in the top vulnerabilities, we saw that in the general sample, we had this, for example, this list of the top vulnerabilities which we found, and we started to go through of this list because it was like kind of made us think whether this is interesting. This is the single most common vulnerability we found. It was reported a year ago, a problem in BusyBox, and I let you read the description, but I think the last last sentence is really funny because not just that the attacker can take over your container, but can also change your terminal color, which is kind of funny to think of, that this is what an attacker is looking for. But if we are looking at in a cloud-native environment whether this vulnerability can be exploited, it's really hard to think that a terminal-based attack can be effective in a cloud-native environment, because only if an attacker is connecting to the container with the shell, starting a shell in the container, sorry, not the attacker, a victim is connecting a shell to a container, and then the attacker can send a DNS record back to this shell with some crafted shell code, and can take over the shell of the victim, who is not actually the workload itself. It is really hard to think that it's a common scenario in our case. The same goes to the second one, libgcrypt. It is only used in 99% of the containers. Libgcrypt is only used for package installation. So if you are not installing packages during the runtime of the container, there is no way the attacker can exploit this. The third is an SQL-based attack. Actually, we thought that an SQL injection in SQLite, if the application uses SQLite, there might be a way to exploit this. But again, not really. I think it's very, very hard. So we did an opinionated filtering of the list, and it turned out that most of the vulnerabilities are not really hardly exploitable in a cloud environment. So it was kind of strange. We went to the graduated projects, did the same thing. We looked at the first vulnerability, which was the most common by far. It turned out that actually this is not a real issue, but a bug in the vulnerability scanner itself, because a misidentification of a software package. So went through all the others. We did the filtering. We see a little bit more vulnerabilities which might be exploited, but again, a lot of them not. So if we are looking at returning to the whole sample and counting how many vulnerabilities in average an image has, you can see that in the general sample, you have much more vulnerabilities. So if you're taking from a general sample an image, a random image, you will find much more vulnerabilities than a graduated project image. And we said, okay, like super nice, CNCF is awesome, like the world use CNCF project, okay, and you won't have any problems, but we are not big believers like automatically. So we said, okay, let's wait a second. Something is not very right here. And again, returning to the original saying that a vulnerability which is returned by the vulnerability scanner is not necessarily something that the attacker can exploit. And we created in the Kubescape project a very neat way to filter out vulnerabilities which cannot be exploited inside the container image. It's called relevancy. And just in a nutshell, the way it works, it identifies which software packages are loaded into the memory during the container runtime, and which are just there because of different reasons, but are not really used during the runtime. Therefore, it's able to filter out all the vulnerabilities which are not relevant, which are not loaded into the memory, therefore not exploitable. And the results, we retested it and tested it with a lot of workloads, which are well known. I have Redis, Nginx, Elasticsearch, Kafka, Zookeeper, and so on here, and compared the relevancy of the results. And you can see that the before is without the pure scanning. The after is actually after the filtering. You can see, let's take, for example, Postgres, which the last one here. So the Postgres is returning more than 1,000 vulnerabilities by default. But after checking the runtime, I don't remember the exact number, but it's I think the fifth of it, or 20% are actually loaded into memory. So 80% we can throw away. So we redid the checks, we rerun the whole comparison, and based on the relevancy information, and now you can see a much more I would say, a complete picture, because you can see the critical number of critical vulnerabilities in average is more or less the same. Even in the general sample, if we are taking into account relevancy, there are a little bit less high vulnerabilities than in the graduated sample. In medium and low, you can see much more, but you can see a much closer comparison of these two than the one before. So I think it gives you a much better sense that where the world is in the sense of vulnerabilities inside container images. So still we see that somewhat better, the graduate projects had somewhat better results, not by far, and we try to explain why. And also I will tell you that the relevancy feature, which I talked to you about, was less affecting the graduated projects than the general population. And the reason is that obviously we know that most of the CNCF projects are based on Go and can run without an extensive base image, without too many external libraries and so on. Therefore, the probability that there is something which is a vulnerability found inside the container image, there is most likelihood that it will be loaded into memory. Therefore, it is going to most likely that it will be relevant. Therefore, Golang has its own behavior, and this is why it is distinguishable from the general population. In general, I think that CNCF is making some strides to really create a quality control around this open source project, and I think it's working to some extent. And I think someone who is part of the tech security effort in CNCF, and I see that how these projects are audited, how they are trying to keep up with some best practices. So I think it makes sense, that some quality control around that has effect, obviously, on these kind of statistics. So if we're looking back at these two parts of the talk, one is the vulnerability part and one is the misconfiguration part. So I wouldn't say that graduated projects or open source projects are less prone to vulnerabilities, and I'm saying for sure that supply chain attacks have might be some more prevalence in open source projects, because sometimes you are receiving code from someone who you don't know, and if there are no controls inside how the open source project works, you might accepting code which is actually bad for your security or very bad for your security. And I think that there was an event in Kubescape when we received the pull request, which was very bad for our security, and but we identified it and didn't accept the contribution. Also, vulnerability scanners are not very, so it's best effort from the industry. Personally, I have some mixed feelings about vulnerability scanners and the results they are giving. One of the reasons is that they are saying to you what vulnerabilities you have, which are publicly known vulnerabilities, but they obviously won't find you vulnerabilities which are unknown, or what they call 0 days. But it's still something that the best thing we can do right now is to keep vulnerabilities inside our containers as low as possible. So while we don't find out that ChatGPT will solve this problem, okay, we have to keep up with this. In the misconfiguration part, I think that generally speaking, the graduated projects had somewhat better output. Not by far, but I think it's most likely that it is connected to the fact that most graduated projects are more seasoned in Kubernetes and they understand more the configuration when they are defining things than the general population. But there is a lot of work to do there as well. So I don't think that there is a huge difference. Slightly better in the graduated projects. I think we have a better state there. So this was my talk. I really, encourage you to try out and improve your security, either with Kubescape or not Kubescape. Go to CNCF, join Tech Security if you're interested in the CNCF security space. I think it's a great thing, great community to work in, and I was very happy to join you here today. Thank you.
Thank you. It was a great talk. Can we have a list of the graduated projects?
Sure. Yeah. I will try to find it, but it was nothing very specific. We just went into CNCF homepage, listed there is the landscape, CNCF landscape subpage, when you can just filter out, and we took out the names okay. One by one. That was it.
Cool. Thank you.
Yeah.
So thank you for the nice analysis, and it's rare to see security talks nowadays which end in a hopeful note. Like usually it's like, oh, management is cutting costs, and security, we're all vulnerable, and so on. And so I wanted to ask, so basically I noticed that you dismissed a lot of the vulnerabilities, even those that had like critical and high ratings. And I wanted to ask, so imagine in a situation with like limited time, resources, maybe some fast-moving startup environment. So is there some, vulnerability rating or compliance to follow that's more pragmatic to use in some more guerrilla environment?
Oh, I think it's like I asked you to ask this question, but it's not. I think it's a great question. So actually, the things the compliances which I know, which is SOC 2, ISO, and PCI, looking at this from different angles. In SOC 2 and ISO, mostly what you need to show is actually that you are aware of the vulnerabilities and you are fixing them. It doesn't really explain to you, the actual number of you have to you mustn't have a critical vulnerability inside your production cluster. And actually, I have to tell you that PCI, I don't know how much of you work with PCI here, but PCI, as far as I know, doesn't require you as well the same. So they are saying that you shouldn't put a critical vulnerability in your production knowingly. So if there is a critical vulnerability, for example, you've installed, I don't want to say a project name, but Project X inside your cluster, and there was no critical vulnerabilities. And 2 days after, there is a new CV because someone reported a critical vulnerability against Project X. Now it turns out that you have that there is a critical vulnerability in your production. So PCI doesn't require you to run and stop your production and change it within 2 hours because, for example, if Project X is a database, it is really hard to swap out the database version in such a fast notice. So I think that but they do require not to put something critical knowingly. The approach, and I'm saying it as as part of a small startup. What we're doing is actually we're taking into account this relevancy information, which is available. It's right now in beta state, but we are using it for 3-4 months already in our production. So we are filtering out 80% of our vulnerabilities is gone. Okay, they are irrelevant. I'm also filtering out all those vulnerabilities which are not network exploitable. So if you remember, there is this strange string of what is called the CVSS attack vector, which describes the vulnerability in very, very binary sense that whether you can exploit it from a network or you need to be on the same machine. So I'm not really concerned about someone is breaking into AWS Stockholm data center and will try to attack my workloads inside the AWS data center. So I'm more worried about someone is coming from the internet, and therefore we are looking only on those vulnerabilities which can be exploited through the network, and there is a flag inside every CV which tells you that. So this is how we are managing our vulnerabilities. Thank you very much.
Thank you very much.